Welcome to the world of maths. This is Christabel and you're watching my YouTube channel KRISY'S Maths Academy. If you're watching my channel for the first time, this is to inform you that this channel contains videos for those who need coaching on their quantitative aptitude, which is required for quantitative exams such as bank exams, RRB, PSC, etc. So also do share these videos to your friends who are preparing for these exams, and also please don't forget to subscribe to my channel and click on the bell icon so that you will get notifications on my next video. Okay, so in the previous video we had discussed on three problems, that is on number series and AP. In this video we will work out on three more problems which will have the topic number series, AP that is arithmetic progression, and GP that is geometric progression. Okay, so let's go to the first question. So the question is, how many terms are there in the sequence 3, 6, 12, etc. 384? Also find their sum. Okay, so I put question number 4 because already in my previous video I discussed on three problems. Okay, so now let's work out on this question. So first I'll write on the sequence. Okay, the sequence is 3, 6, 12, etc. 384. Okay, so first of all I must find out the pattern of the sequence, whether it is an arithmetic progression or a geometric progression. Okay, now in case of arithmetic progression, the pattern is to add a constant. Okay, so what I will get, how will I get 6? What number should I add to 3? I must add 3. Okay, so if I add 3 to 3, I will get 6. So again I need to add 3. 6 plus 3 is 9 but not 12. So it is not an arithmetic progression. Okay, so let's try about geometric progression. 3 into 2 equals 6. Okay, and 6 into that common ratio 2. What we'll get? We'll get 12. So we understand that this is a geometric progression. Okay, so I write down it as GP. Now let's take out all the notations from this pattern. Okay, that is the first term A will be 3, then the common ratio R is equal to 2. Then what else we have? We have the last term or the nth term AN. AN equals 384. Okay, now if AN is 384, what we have to find? How many terms are there? That is n. So n equals question mark. Also we need to find the sum. Sn equals question mark. Okay, so now let's write down the formula for the last term in a geometric progression. That is AN equals A into R raised to n minus 1. Now let's substitute these values in this formula. Okay, that is 384 equals A, that is 3 into what is R, 2 raised to n minus 1. Now 384, 3 plus 8 plus 4 is 15. So it is divisible by 3. So I bring down 3 here. That is 384 divided by 3 equals 2 raised to n minus 1. 1s are 3, 3 2s are 6, balance 24, 3 8s are 24. That is 2 raised to n minus 1 equals 128. Now we have to find the value of n, but it is in the power. So how we can equate it, how we can find the value? What we have to do is, in the LHS side it is 2 raised to a value. if we make the RHS side also in a similar pattern, that is 2 raised to a value, then these two powers will be equal. Okay, so 128. So to get 128, we need to learn certain values. For example, 2 raised to 5 equals 32. Then 2 raised to 10 equals 1024, etc. We learn these values, it will be easier to calculate. So I need the value 128. It is anyway surely 2 raised to a value because it is equal to 2 raised to n minus 1. Okay. So 128 is between 2 raised to 5 and 2 raised to 10. So let's find out the values between them. Okay. So I put 2 raised to 6. 2 raised to 6 will be 2 raised to 5 into 2. That is 2 raised to 5 is 32 into 2. 32 into 2 is 64, right? Then it is not equal to 128. I'll try the next number, that is 2 raised to 7, which is 64 into 2. I get 128. So the value here is 2 raised to 7. So I put 2 raised to n minus 1 equals 2 raised to 7. So since the base is equal, their powers also will be equal. Therefore n minus 1 equals 7, n equals 7 plus 1, that is n equals 8. Okay. So the number of terms in this sequence is 8. There are 8 terms. Now next we have to find the sum. Okay. So we have got the value n equals 8. So I'll write it, n equals 8. Now we have to find the sum Sn. There are two formulas for Sn, right? That is, if the common ratio is greater than 1. In this case, common ratio is greater than 1. So we'll use that formula. That is, Sn equals A into r raised to n minus 1 divided by r minus 1. So let's substitute the values to get the Sn value. So that is equal to A, that is 3 into r is 2. 2 raised to n. N is 8. 2 raised to 8 minus 1 divided by 2 minus 1. So I'll write it as 3 into, what is 2 raised to 8? 2 raised to 8 is 2 raised to 7 into 2. That is 2 raised to 8 is 128 into 2. So what I get? I get 256. Okay, it is 256 minus 1 divided by 2 minus 1 is 1. So it is 3 into 256 minus 1 is 255. 3 into 255. So I multiply 255 into 3. I get 765. So the sum is 765. Okay. Now the next question, that is question number 5, is 1 minus 1 by n plus 1 minus 2 by n plus 1 minus 3 by n plus etc. up to n terms. Now in this case, it is not an arithmetic progression or a geometric progression, because in arithmetic progression it is to add a constant and in geometric progression it is to multiply a constant. So I already told in my previous videos that there are sequences in which it will contain a combination of the operations of addition, subtraction, multiplication and division. So still we have to find a method to solve this. Okay. So how we can do? We have to separate, make groups and find out. It will be different for different problems. Now let's see about this problem. In all these terms, 1 is a common. So I can put 1s separately, and then 1 by n, 2 by n, 3 by n, etc. I'll put it separately. So let's see what happens. Okay. So this will be equal to, I group all the 1s together. Okay. That is 1 plus 1 plus 1 plus, how many 1s will be there? It will be up to n terms. So I write up to n terms. Then the second terms are all minus. So I take the minus outside and group all these together. All these, it will be the sum. That is 1 by n plus 2 by n plus 3 by n plus etc. 1 by n plus 2 by n plus 3 by n plus etc. And it will be up to n terms. So what will be the last term? The first term is 1 by n. Second term is 2 by n. Third term is 3 by n. So the last term is n by n. Okay. So plus n by n. Okay. So now let's go to the next step. This one is added n times. So if it is added n times, it is 1 into n, that is n. So the first group, the answer is n. Now let's see about the second group. Minus of, in this the denominator is common. So I put the denominator down and I add the numerator. That is 1 plus 2 plus 3 plus etc. plus n. 1 plus 2 plus 3 plus etc. plus n. Okay. Now what about the numerator? It is the sum of n natural numbers. So we already know the formula for that. So I write it is equal to n minus this 1 by n, I will keep it outside, and here 1 plus 2 plus 3 plus etc. plus n. I will write down the formula for the sum of n natural numbers. That is n into n plus 1 divided by 2. Okay. Now in this term, n is multiplied as well as divided. So we can cross off. So we get n minus, what we have rest? N plus 1 divided by 2. Okay. So there is no denominator for this, but for this there is a denominator. So I must make them in equal denominator. So what I do? I multiply 2 into n. So let's see what happens. 2n minus, what is in this? N plus 1. N plus 1 whole divided by 2. Okay. Which will be equal to 2n minus of, minus is applicable for both the terms. So minus n minus 1 divided by 2. Okay. What is 2n minus n? It is n. So that will be equal to n minus 1 divided by 2. So this is the answer for this sum. Okay. Now the next question is, the sum of how many terms of the series is 1800, and we have the series 6 plus 12 plus 18 plus 24 plus etc. and the last term is not given. So this is somewhat like an indirect question. So anyway, we have to find the number of terms, that is n. And we have the sum, that is Sn. Now we have to find out whether this is an arithmetic progression or a geometric progression. Now 6, if I add 6, I will get 12. Again if I add 6, I will get 18. And again if I add 6, I will get 24. So this is an arithmetic progression. Okay. So let's write down what all values we can take out from this pattern. That is, the first term, a will be equal to 6. The common difference d will be equal to 6. What about an? We don't have an. What else we have? We have the sum of the series, that is Sn. we have Sn equals 1800. So what we have to find? We have to find the value of n, right? Okay, so now let's write the formula for arithmetic progression. First let me write the formula for the nth term, that is an, okay? An equals a plus n minus 1 into d. So in this I don't know what is an and I don't know what is n. There are two unknown variables. Let's see the formula for the Sn. Sn equals n by 2 into a plus an. So here also an and n are unknown. We know what is n, Sn, okay? So what we do? We combine these two equations so that we can find the value of n. How I can do? In this Sn, an is unknown. So I'll substitute this an value in this Sn and let's see what's going to happen. Sn equals n by 2 into a plus an, right? So I'll put a plus, instead of an, I'll write out this formula here. It is a plus n minus 1 into. So now let's substitute the values in this formula. I get Sn can be written as 1800 equals, n is unknown. So I write n divided by 2 into a. A is 6. 2 into 6 plus n minus 1 into d is 6. Right? Now I can multiply 2 into 1800, but I will get a bigger number. So instead of that, let me see how I can cancel 2. In this 6 is common. So if I take 6 outside, I can divide 6 by 2. So what I'll do? 1800 equals n by 2 into 6. If I take 6 outside, what I get balance? 2 plus n minus 1, right? So I cross it, I'll get 3. So this will be equal to 3 into n into what we have here, 2 minus 1 is 1. That is n plus 1, okay? So 1800 equals 3n into n plus 1. Let me write it down. (1800) equals 3n into n plus 1. Now 1800 is divisible by 3, okay? So I just bring this 3 down and I just cross it. 3 into 6 is 18. So if I cross here, I'll get the value 600. And in the RHS, n into n plus 1 can be written as n square. I am multiplying n in these two terms. So I'll get n square plus n, which is equal to 600, right? So it will be n square plus n minus 600 equals 0. Now just check this equation. This is a quadratic equation. So there will be two values of n, okay? So what I had to do? I had to factorize this equation and find out the two values of n, okay? So by factorizing, it is minus 600. After factorizing, I find that minus 600 can be written as minus 24 into 25, and the middle term can be written as 25 minus 24, will get 1. That is 1 into n, okay? I have not done any video on factorization, but I will be doing a video soon. And if you have any doubts on factorization, you can check on that video. It will be, once it is done, I will add the link of that video in this description box. So it will be easy for you to understand. Okay, so let's factorize this quadratic equation. It will be n square plus 25n minus 25n minus 600 equals 0. That is, if I have to group, I take n common, n plus 25, and in this I will take 24 common, minus 24, n plus 25 equals 0. Now I take n plus 25 common, balance we have n minus 24. N plus 25 into n minus 24 equals 0. So the two values, so n, either n plus 25 equals 0 or n minus 24 equals 0. So if I can write n equal to minus 25 and 24. If we equate n plus 25 equal to 0, n equal to minus 25. If I equate n minus 24 equal to 0, I will get n equals 24. Now the value of n, it is the number of terms. So it should be positive. So in these two answers, which is positive? 24 is positive. So the final answer is n equals 24. Okay. So hope you understood, and if you have any doubts, please comment in the comment section of this video, and in my next video I will be discussing on word problems of AP and GP. Okay, so see you in my next video, and click on that bell icon so that you will get notification when I upload my next video. Okay, so bye.